So for this problem, we're using trig identities and algebraic methods as necessary to solve the following trig equation. We have to identify all possible solutions by including all answers in the range 0 to pi. If necessary, we have to round the answer to 4 decimal points. And if there is no solution, we have to indicate via writing no solution. So we have our equation, 2 root 3 tangent x minus 2 equals 0. I've shown out the first couple steps to get tangent x equals 1 over root 3, but we want to rationalize that denominator because we don't like our denominators to have a radical in them. So to do that, we simply multiply by root 3 over root 3. And what this does, once we multiply across, we get something like this. And this can simplify it down to, because the square root of 9 is simply just 3, root 3 over 3. So now we could rewrite this as tangent of x is equal to root 3 over 3. So now we want to find that angle in which gets us root 3 over 3. So I've pre-written down the steps here. So pretty much we know that tangent is equal to sine over cosine. And I wrote the values down in the first quadrant at least for both cosine and sine. So pretty much what you do, if we want to find tangent of pi over 6, we do 1/2 over root 3 over 2, which when we keep change flip, we get a similar answer. We had 1 over root 3, and to get back to that root 3 over 3, we did what we did on the previous slide, and we see that that is actually our answer. We could also do this for tangent of pi over 3, where we get root 3 over 2 divided by 1/2, where we do the same kind of thing, we get root 3. So we can see how it varies between two trig functions. So what is important here too is the fact that we were on the range 0 to pi. So you're thinking, why can't we use this quadrant here? It's because tangent would be negative there. We remember that all trig identities are positive in the first quadrant, only sine is positive in this quadrant, so tangent itself would be negative.